Welcome to this explainer. Okay, today we're diving into a highly detailed step-by-step look at fixing a very specific, kind of frustrating issue, repairing a Tesla Model 3 seatbelt buckle. But here's the twist right up front. By the time we wrap this up, we're going to uncover exactly why attempting this highly technical fix yourself might actually be a terrible idea. We're drawing from a really fascinating write-up by Herrick Hu over at EV-PowerShare. He documented his entire mechanical journey so, well, we don't have to go in blind. So buckle up, pun absolutely intended, because we are going deep into the anatomy of a Tesla seatbelt system. Now, before we get our hands dirty, we absolutely need to highlight this massive disclaimer right from the source. The author states, and I quote, "My actual recommendation is simple. Just buy a replacement seatbelt buckle assembly online and replace the whole unit." And honestly, that's the lens we're looking through today. This explainer is strictly for informational purposes. The author takes zero responsibility for any damage you might cause to your vehicle, your wiring, or, yourself. So while we're going to learn the exact teardown and repair process, the ultimate lesson here is that a direct replacement is safer, faster, and just far less risky. But hey, knowledge is power, right? And understanding how the system actually works is completely fascinating. All right, let's dive into this. Here's our roadmap for exactly how this teardown and attempted repair is going to unfold. First, the warning and the problem. Second, confirming it in service mode. Third, accessing the buckle assembly. Fourth, exposing the circuit board. Fifth, soldering and sealing it. And finally, the final test and verdict. Let's get into it. Section 1. The warning and the problem. Every repair story starts with a problem, right? And for a modern EV owner, that usually means a sudden, glaring alert popping up on the touchscreen. For the author, it all started when the car threw a Safety Restraint System alert, specifically error code RCM_AO94. If you own a Tesla, seeing a safety restraint issue just instantly makes your stomach drop. Now, this error usually points to a seatbelt component problem. After some digging, the author realized this is actually a pretty common issue. Why? Well, it turns out that from the factory, the rear middle seatbelt buckle wiring sits under a lot of tension and is zip-tied directly to the chassis. You can almost feel the frustration here, right? Just a tiny wire stretched a bit too tight, eventually snapping and causing a critical safety alert that simply refuses to clear. Section 2. Confirming in service mode. So before we start ripping back seats out of the car, we need absolute certainty on what is actually broken. We've got to move from a general error code to a specific, localized fault. And this brilliantly illustrates one of the coolest features of a Tesla, service mode. Let's energetically walk through exactly how you tap through the center touchscreen to access these hidden diagnostic tools. First, you tap Controls, the little car icon, and then go to Software. Next, you press and hold the large model text for about 2 to 4 seconds. When you let go, a prompt pops up. You just type the word Service and confirm. Just like that, you're in. From there, you navigate straight to the Seats section to check out the live status for each individual buckle. Now, the real value of these live status diagnostics became super clear when the author actually had to reach back and gently wiggle the wire to get the smoking gun to appear on screen. But the moment it did, the system spit out the exact hyper-specific fault code, VC-right_A29_buckle faulted rear C. Boom. That confirmed without a shadow of a doubt that the rear center seat buckle sensor was the culprit. Knowing exactly what they were dealing with, the real physical work could finally begin. Section 3. Accessing the buckle assembly. Okay, time to shift gears from digital diagnostics to physical labor. We got to get that faulty buckle out of the car. First up is removing the rear seat. As the author notes, popping the seat out is surprisingly easy. Do that, and you instantly have access to the center seatbelt buckle. But while getting to it is a breeze, actually detaching the center buckle from the chassis, that introduces our very first massive physical hurdle. The bolt holding it in place isn't just screwed in, it is heavily secured with thread locker right from the factory. And man, this brings us to a true test of physical endurance. Tesla's official service manual actually recommends using heat to soften that thread locker. But the author didn't use heat. Instead, they had to slide a massive 3-foot-long PVC pipe over the end of their wrench just to get enough leverage. Imagine the tactile struggle here, trying to crank a 3-foot pipe inside the cramped back seat of a car. The author noted that for the first 15 or so quarter turns, it literally felt like absolutely nothing was happening. But eventually, with enough brute force, that bolt finally broke free. Section 4. Exposing the circuit board. All right, with the buckle finally out of the car, we shift focus from brute force to, well, delicate surgical extraction. Opening this assembly is a multi-step process. First off, the author discovered the right and center buckles are literally glued together. Once you manage to separate those, the mechanical buckle housing opens up with 2 hex screws. Inside, you have to very carefully separate the delicate sensor wiring assembly from the heavy mechanical part of the buckle. The author just used a small flathead screwdriver to gently pry it straight off sideways. Now, what's really interesting about this next part is an incredibly candid admission of a pretty frustrating mistake. The sensor assembly is totally embedded in this soft, black, rubber-like material. Initially, the author used pliers to painstakingly pick this rubber off bit by bit. They noted it took absolutely forever. But here's the crucial pro tip they shared. Just use a heat gun. It melts the rubber away super easily. So if you're ever doing something like this, save yourself the headache and use heat right from the start. So once that rubber is finally out of the way, a tiny circuit board is exposed. The damage to the wire wasn't actually visually obvious, so the author grabbed a basic multimeter. By sticking one probe between the 2 wires right on the circuit board, it made testing the connector pins so much easier. They checked each pin end to end, and bam, there it was. The black wire was completely dead. It wasn't conducting electricity at all. They found the exact physical break, which perfectly sets up the actual repair. Section 5. Soldering and sealing it. This brings us to the most intricate part of the teardown. It's soldering time, but it's also right here where a crucial, completely avoidable mistake happens. The author initially thought, hey, I'll just remove the tiny pin, clamp a new wire in, and call it a day. Bad idea. Seriously, do not do this. That pin is incredibly small and precisely crimped from the factory. While you technically can release a tiny clip to remove it, unclamping it without wrecking it is nearly impossible. The author candidly admits they damaged the pin for absolutely no reason. This is a massive what not to do moment. The much better, safer approach? Leave the pin alone. Just cut the bad wire right below the pin, leaving enough length to comfortably solder your new connection. Okay, let's walk through the actual repair steps sequentially. Step 1, you solder a new black wire to the circuit board and to the existing pin that you wisely left alone. But listen to this critical warning from the author. You have to make absolutely sure the red and black contacts do not touch during soldering. Step 2, grab that multimeter again and test the continuity to ensure your solder joint is rock solid. Step 3, carefully shrink wrap the repair to protect it. And step 4, zip tie the 2 wires together tightly in a few places. This is absolutely crucial because it reduces the exact tension on the repaired section that caused the wire to snap in the first place. With the electronics patched up, it's got to be sealed back together to survive the harsh environment inside a moving car. You reinsert the circuit board into the sensor housing and use that trusty heat gun again to remelt the black rubber over it. And here's a pretty funny detail from the author's journey. Because they painfully picked off and threw away way too much of that black rubber earlier on, they actually didn't have enough left over to seal it properly. They literally had to supplement the missing rubber with standard superglue just to fill the gap. A fantastic reminder to hold on to your scraps when you're taking things apart, right? Section 6. Final test and verdict. We've reached the climax of our explainer. We've diagnosed it, extracted it, exposed the board, soldered the wire, and sealed it up. Now it's time to put it all back together and see if this grueling effort actually paid off. Reassembly is basically just the whole process in reverse. You reinstall the buckle assembly into the chassis. And yes, that trusty 3-foot PVC pipe makes a triumphant return appearance, giving you the leverage you need to properly torque that massive bolt back down. You reconnect the green and gray electrical clips under the seat, pop the cushion back in, and finally re-enter Tesla's service mode to check your work. And here is the mechanical victory. After literally sitting on the seat and buckling in just to trigger the sensor, the service mode diagnostic screen lit up showing all green. The repair actually worked end to end, and that dreaded safety restraint fault code was completely gone. The authors successfully reverse-engineered and fixed a highly specific factory flaw. It's a great feeling. But that brings us to a final, really provocative thought. The author asks themselves, would I actually do this again? And their honest answer? Probably not. Honestly, despite the success, the sheer amount of time, the need for precision micro-soldering, and the risk of messing up a critical safety component just aren't worth it compared to simply buying a replacement buckle assembly online and swapping the whole thing out. But hey, by walking through this, we gain a profound understanding of what's actually happening beneath the seats of these incredible vehicles. It really leaves you pondering the true value of DIY, doesn't it? Sometimes the absolute best lesson you can learn from a repair is knowing exactly when not to do it yourself. Thanks for joining me on this explainer, and keep staying curious.